Welcome back to Math 107 College Algebra. In this video, we're going to take a look at how to solve a system of nonlinear equations. So I'll give you the system. X squared plus y squared equals 1. And y equals x squared. So there are actually multiple ways we can solve this. All of them are going to involve using substitution differently. Now if we take the naive approach and use substitution as we had previously, the second equation is already solved for y, so we can go ahead and plug that in. So we have x squared plus x squared squared is equal to 1. And actually leaving it like this does make for a very nice u substitution. So we can go ahead and work that. And then subtract 1 from both sides. Reordering, I get u squared plus u minus 1 equals 0. And then we can go ahead and use the quadratic formula to find u. So negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 1 all over 2 times 1. I won't bother putting the 1 there. So it ends up being negative 1 plus or minus the square root of 5 over 2. And then we'll plug that in as u to figure out what x is. So x is going to end up being plus or minus the square root of that ugly number, although one of them is invalid because it's going to be taking the square root of a negative number. And then we need to plug that in to figure out what our y value is going to be. Y value or values, as the case may be. But this is a very naive approach as far as working these systems of equations. What we could do to make our life easier with substitution, I'll use the same problem. So now, instead of doing the substitution with x or y, I'm going to make the substitution with x squared. So I have y is equal to, y plus y squared is equal to 1. Subtract 1 from both sides. And I could have reordered that too. And now I plug that into the quadratic formula to find y. And then go back to find x. And of course there is always the graphical method you can use to find these solutions, which in a lot of cases will end up being easier. As we can see from stuff like this, I'm not going all the way through to the answer because it's going to require me numerical methods to get there, because I do not want to mess with roots of roots. So, that's how we solve systems of nonlinear equations, just a background idea. We're going to be talking about it mainly from the graphical standpoint in class on Tuesday. I will see you then.